All right. Hi everyone. Welcome to the third offline lecture, but the fifth lecture throughout for this week. Today we're discussing asynchronous versus synchronous functions, real world use of callbacks. We've used callbacks until now, but they're actually really effective or like really needed in an asynchronous function. You don't really need them in synchronous function like we've used until now. JavaScript browser architecture. How does JavaScript run inside the browser? Promises and async await. These are the high level 4 concepts we need to discuss. Let's get right into it. Number 1. What does synchronous mean and what does asynchronous mean? I'm talking about these async versus sync functions. What does synchronous generally mean in English? Synchronous means together, one after the other, or sequential. These are sort of Prayavachi or synonyms to synchronous. It means something that runs one after the other or things running sequentially. Synchronous and sequential are sort of interchangeable. Only one thing is happening at a time. Let's think of this in a real world use case. Let's say you're trying to cook food, you're trying to cook Maggi. If you turn on gas, then boil the water and look like while the water is boiling, you keep looking at it. Once the water is boiled is when you go and start to chop vegetables. Once you're done chopping the vegetables, you go out and pick the masala and then you finally put the masala in, then you put the Maggi in. If you're doing all of these things one after the other, that is a real world example of you being synchronous, you doing only one thing at a time. Compare this to asynchronous. It is the opposite of synchronous. It means things are happening in parts. Things are happening parallelly somehow. Multiple things are context switching with each other. For example, it might happen that you ask your friend and tell them, bro, please chop the vegetables while I'm boiling the water. Or you start boiling the water and then you let it be. You let it boil on the side. You let it go from 0 degrees Celsius to 100 degrees Celsius while you are chopping the vegetables. So there are two tasks happening parallelly. That is high level what asynchronous means. And what is synchronous? Synchronous, as the name suggests, is sequential. Only one thing happening at a time. You're not able to parallelize things. Let's build some intuition for asynchronous and synchronous functions. Human body and brain is single-threaded. If you really think about it, humans can only do one thing at a time. We can't really multitask. We can only do one thing at a time, but we can context switch between tasks or we can delegate tasks to other people. I, as a human, can only do one thing at a time. If you tell me to cook, I will, as I said, first try to boil water, then I'll try to cut vegetables, then I'll try to take out Pepsi from my fridge, then I'll try to go back and look at whether or not my water is boiled. I can only do one thing. I don't have 10 hands. I have 2 hands, but at a time, if you high level think of it, the human brain is sort of single-threaded. We can only think of one thing at a time. But we can, number 1, context switch, which means I can go to the boiling water, check if it is boiling. Okay, it is boiling. Middle of the task, I can go and chop some vegetables. While I'm chopping vegetables, middle of the task, I can go and get something from my fridge, go back to the vegetables, go back and look at the boiling water. So I can context switch between tasks. But at a single time, I'm only doing one thing. Number 2, how else can I parallelize? I can call a friend. I can delegate tasks to other people. I can be like, bro, I'm boiling the water. You please cut down the vegetables. So human brain, even though being single-threaded, can somehow do multiple things at the same time by either context switching or delegating tasks to other people. The same is true for JavaScript. JavaScript is single-threaded, but it can also context switch and delegate tasks to other sort of processes. We'll see how that happens. Let's say you have 4 tasks. You have to boil water, you have to cut vegetables, you have to cut the Maggi packet or open the Maggi packet. Maggi is basically a famous noodle in India. And lastly, you have to get ketchup from the shop nearby. You have to do these 4 tasks. Now it's on you whether you want to do them together, parallelly, sequentially, but you have been given these 4 tasks to create Maggi as an output by the end. How would you do this? Would you do this synchronously or would you do this asynchronously? Let's look at both of these cases. All right, so this is the problem statement again. Feel free to pause here and look at the problem statement. I'm going to first show you how you would do this synchronously. Okay. If you're doing this synchronously, as you can see, there's an angry woman here because she's very angry because she's doing it synchronously and that is going to make her really slow. Number 1, she puts the water on boil and stares at it while it goes from 0 degrees Celsius to 100 degrees Celsius. That is her first task. She's only focusing on her first task. She's doing it synchronously. Once that is done, she goes here and starts to cut the Maggi packet. Let's say it takes her 2 minutes to cut the Maggi packet. That's the total time by now is 5 plus 2 equal to 7 minutes that she has spent trying to make Maggi. Then she goes here, tries to cut vegetables. That takes her another 10 minutes. And lastly, she goes to the shop, tries to get a packet of ketchup and comes back home. Total time taken 37 minutes. As you can see, she's an angry woman right now. Why? Because she did things sequentially one after the other. This is so dumb. It would have been so much better for her to just call a friend or like tell her sister, okay, bro, please go and get ketchup from me while I do these 3 tasks. They could have parallelized, but she did not do that. Why? Because she's a angry synchronous creature. Now let's look at how you would do the same thing if you were allowed to parallelize somehow, if you could do some asynchronous things. Or could you multitask? More technically, could you context switch and could you delegate your tasks? Let's see. This is a happy person now. He is open to parallelizing creation of Maggi. He is open to context switching. What does he do? He turns on the gas, takes 2 seconds. forgets about it, doesn't look at it, doesn't stare at it, doesn't wait for it to go from 0 to 100 degrees Celsius, just turns it on, goes on to delegate the ketchup getting task to a friend. Delegates the task to a house help, tells them, hey, I am doing these 3 tasks. Please do this one task, go out and get me a packet of ketchup. So Kamala Didi has been introduced here. She's also very happy. She is doing her task while this guy is focusing on these 2 tasks that are left. So for the first 2 minutes, this guy cuts Maggie. She is on her way to the shop. Then he just checks on the water for 1 second, just making sure things are on the up and up. The water is starting to boil. And by this time, she's also on her way. It has been 2 minutes and 1 second. She's on her way to get the ketchup, hasn't yet reached the shop. Then this guy is cutting vegetables for 8 minutes. And let's say she's back by then. Let's say it took her a total of 10 minutes to come back from the shop. This guy, in those 10 minutes, spent around 2 minutes here and 8 minutes here. He's still cutting vegetables. It's in the middle of cutting vegetables. She's back with the ketchup. She's waiting for her master. Okay, bhai, please, whenever you're free, let me know. I am here with my bottle of ketchup. Lastly, when 10 minutes happen, this guy's cut the vegetables, so he's good to go. And she's been waiting for 2 minutes to finish. And by this time, since this guy's free, he can take the ketchup from her and, do whatever he has to from here. What is the total time in this case? The total time in this case is 12 minutes. Now this case is slightly different from the last one. Ketchup getting time here has been decreased to 10 minutes, but still it is much better than the last case where you were doing everything sequentially. One thing here was parallelized, and this guy also context switched between boiling and Maggie and this thing. He never stood there to watch the boiling water go from 0 to 100 degrees Celsius. Let's look at it diagrammatically. Turn on the gas for 1 second. This guy does these 2 tasks, takes 12 minutes. This girl takes 10 minutes to get the ketchup, and finally by the end of it, Maggie is ready in 12 minutes. Is this a better approach to create Maggie? Yes. Why? Because you've been able to parallelize tasks. You have decreased the total time to be taken to create Maggie by a lot by parallelizing and context switching. This is the difference between async and sync functions. Whenever you have a synchronous function, you have to wait for it to complete before you can proceed to the next one. When you have an asynchronous function, you can somehow delegate the task to another thread so that it's not running on the same single JavaScript thread, and that single JavaScript thread can do other tasks while this sort of external asynchronous function is doing other tasks, figuring things out. What is a real world example of this? A real world example of an asynchronous function is reading files from your file system. If in Node.js, you try to read a file from your file system, that might take 1 second, that might take 10 seconds. You don't want to wait or run that on the main JavaScript thread. If that runs on the main JavaScript thread, that JavaScript thread is busy trying to read from a file and it cannot do other things. You'd rather delegate that to someone else so that the reading is happening while you are doing your own things. Whenever the file reading is complete, you get back the content and you start to do things with it. Cool. That's a high level. We will see more examples as time goes by. What did we learn until now? Even if you are single threaded, us as humans have a single threaded brain. Brain can only do one thing at a time. You can do things parallelly by either delegating them. You can also context switch between tasks if need be. The net time to do both the things would still remain the same. If you are context switching between cutting Maggie and cutting vegetables, you spend 1 minute here, 1 minute here, 30 seconds here, 1 minute here, 30 seconds here, 1 minute here. Still the total time remains the same. But if you notice the boiling water problem, you can just turn it on and move on to the other things. You don't have to stare at it until it reaches 100 degrees Celsius, right? So you can decrease the total time by context switching between tasks. Okay, bro, turn it on. By the time I will give you 2 minutes to boil. Meanwhile, let me chop some vegetables. Meanwhile, let me open my packet of Maggie. Cool. All right. Net amount of time taken to do tasks can be decreased by parallelizing, by doing these 2 things, delegating and context switching. Cool. This is a real world example. Let's see how JavaScript does the same thing. How does JavaScript does the same thing? Can JS delegate? Can JS context switch? The answer is yes, by using asynchronous functions. What are asynchronous functions? How do you define them? Let's see that next. Until now, we've only seen synchronous functions. Any functions you've seen until now, all the functions you've defined are all synchronous functions. What does that mean? That means if you run this function, the JavaScript thread is busy running it. The control reach here, control reaches here, find sum gets called, control reaches here, and then it goes into the for loop. The JavaScript thread is busy doing this calculation, finally returns it, control reaches here. During the whole process of control going here, and here, the JavaScript thread is busy. It cannot do any other tasks. This function is a synchronous function. Let's introduce an asynchronous function here called set timeout. Now this is a global JavaScript function. JavaScript provides it to you because JavaScript, not exactly JavaScript, this is actually a web API technically, but high level, you can assume that this is a global function that JavaScript gives you. And you can use this to run a specific function after some duration. If you look at the global set timeout function, what do I mean when I say global? I mean you have access to this in the JavaScript. Whenever you're writing JavaScript, you don't have to define it separately. It's just like function is available to you, return is available to you. This is a pre-made function that JavaScript made for you. Okay, use it. This is a very common use case. What is the use case? Running a specific function after some duration, this duration being in milliseconds, which means in this case, when I run this code, control will reach here, function is defined, control will reach here, function is defined, control will reach here. This will say, okay, find sum till 100 needs to get called after 1000 milliseconds, which is 1 second. And then after 1 second, control reaches here, here, and this function runs. The question is, Harkiyat, how is this an asynchronous function? What makes this an asynchronous function? Great question. This is an asynchronous function because when the JavaScript thread reaches here, then reaches here, then reaches here, it does not wait here for 1 second. I repeat, the control reaches here, set timeout is like, okay, I need to call this after 1 second. Cool. I will let you know after 1 second. This is similar to Kamla Didi. You have delegated the task of calling this after 1 second to someone else, and you will proceed to your lines of code that come after it. This is what makes it an asynchronous function. Compare this to it being a synchronous function where you can be like, bro, I'm going to be here and I'm going to be stuck here for 1 second. After, it's like looking at the boiling water, right? Even though I know this needs to be called after 1 second, if I keep staring at it, if I stay here, then that makes set timeout a synchronous function. Can you create a synchronous set timeout function? Yes, you can. But what is the global set timeout function that you have access to? That is asynchronous. JavaScript has written it in a way, okay, bhaiya, control reaches here, that is fine. This will get called after 1 second. You proceed. The JavaScript thread can do other tasks, which in this case is it is going to go and print hello world. Cool. That is what high level one asynchronous function is that JavaScript provides you out of the box. This is a gist for it. Let's try to run it quickly as well. So I'm going to copy it, going to go to REPL.it, create REPL, Node.js create. Would urge you to do the same. Paste, oh, easy. Go to the gist, copy over the code, paste it here and run it. You will see hello world gets logged. And after 1 second, control would reach here and here. There are no logging here. So let me also log, rather than returning, log find sum of 100 here. And now if I run it, hello world, and after 1 second, 4950 gets printed on the screen. Harkiyat, can you show me the other example? Can you make this synchronous somehow? Sure, sir. To make this synchronous, there are a few ways. I'll show you the dumbest one, which is called busy waiting, which basically is, I'm going to define a function, sync sleep, which is going to do nothing. It is going to iterate from I equal to 0 to some very big number and do nothing inside. Maybe do something like this. Now this is a very expensive operation, which is why when the control reaches here, it will be busy here. And rather than doing a set timeout here, I can do something like this, sync sleep call. What will happen? Control reaches here, control reaches here, control reaches here. When the control reaches sync sleep, it goes here and remains busy for 1 second, sort of. We don't exactly know because, it depends on the machine, how much time it takes for this machine to run these many iterations. But assuming this is a big number, it will take some time. And this is one way for you to synchronously sleep the thread, which is the thread isn't really sleeping. It is actually just getting very busy doing something else. And that way you can defer printing this or defer the control reaching here by 1 second by calling an expensive operation here. This is synchronous, which means if I run this, hello world won't print immediately. First, as you can see, it's taking a lot of time because this takes 4 seconds maybe. But first 4950 rendered, then hello world rendered, which means we slept for some time, then this function got called, which logged this thing right here, then hello world got called. But if I comment this line, the sync sleep, and start this line, now even though finds till 100 is above this console.log, set timeout is like, okay, bro, I am not synchronous, I am asynchronous. You tell me I have to execute this, fine. I will execute it after 1 second. JavaScript thread, please proceed and do the next thing, which it does. JavaScript thread reaches here and logs hello world on the screen. Cool. That is why you first see hello world and then see 4950 in this case. Cool. That's a high level of a basic asynchronous function. Let's go back to the slides and proceed a little bit. We will see more visualizations soon. All right. This is how you call an asynchronous function. We've just called it yet. We haven't defined our own yet. We will eventually. This is similar to delegating the task to Kamla Didi. After 1 second, remind me to run a function while this guy proceeds to do its own thing, which is boiling the water, cutting the vegetables, or in this case, calling hello world. This girl's job now is to maintain the clock for 1 second. It is not to get catch up in this technical terms. In this specific example, it is to maintain a clock for 1 second. After 1 second proceeds, this guy, after it runs hello world, this guy will just sit idle. It's like I'm done. All my tasks are complete. I'm waiting for Kamla Didi. Kamla Didi is still running her clock. When the 1 second happens, she tells bhaiya, okay, please run find sum till 100, and then our guy just runs this thing, which will control reaches here and starts executing the whole thing. Still the code is executed by this guy, but the 1 second callback has been delegated to Kamla Didi here, so that the thread remains free. It's not dependent on Kamla Didi. Cool. Hopefully that was clear. Async or sync functions. What are the common async functions? Cool. Take a pause here. Feel free to look at the code. Feel free to understand how set timeout is different from a busy wait where the thread remains busy. Here the thread will be free. Feel free to take a pause. I'm going to introduce a few other async functions that JavaScript provides you out of the box. We will eventually write our own, but for now we'll just focus on the asynchronous functions that JavaScript provides to us. We saw one which is set timeout. Another one is fs.read file. This is for reading a specific file in your file system. If you are using Node.js, you are running the JavaScript file locally, your JavaScript file can read other files, text file, MP4 file, JSON file. It can read those. That is also asynchronous. Why? Because you can't really read a file immediately. There are a few things. If a Node.js process is trying to access a JavaScript or a TXT file, it might take some time for it to get access to it because that file might be logged. That file might have some other a process that's trying to execute it. You might be trying to editing it in a different process. So you can't immediately say, if you try to read a file in Node.js, you will get access to it immediately. For that reason, this is also an asynchronous function. Whoever is calling this, delegate the task to someone. That guy will read the file, try its best to read it in 1 second, 2 seconds, 3 seconds. When it is done reading, it will call a callback on you, and you can execute logic after that. Cool. Last thing is fetch. Feel free to ignore this. This will come to eventually, but fetch is something to fetch data from API endpoints. So if you know this already, fetch is also an asynchronous call because you're getting data from someone else's server, which might be in the US and UK. But if you don't get it right now, feel free to ignore. We will get to this next week. Cool. This is a high level of async. A few async functions that JavaScript provides you out of the box. Let's write the code for another async process to read a file in your file system. Cool. Again, if you don't have Node.js locally, it is fine. We can just write the code in Replit here. So if you go to Replit, do one thing for me, add another file here and call it a.txt and put some content inside. You can put whatever you want. I'm going to say, hi there from a.txt. Cool. Save it, go back to index.js and write some code with me. Const fs equal to require fs. Harkirat, what is this? Never seen this before. Don't worry about it. This is basically, 1 second. All right, as I was saying, this is just requiring an external library called fs. It stands for file system. It's basically a Node.js library that lets you do a few things like reading from a file, writing to a file, which is what we want to do. Don't worry about the syntax too much at the moment. We will later on come to how you can actually import other modules that are important, for example, Express. For now, just try to follow along. This gives you access to a function called read file, which, as the name suggests, if you give it the path to a file, which I am a.txt, and give it one more parameter, which don't worry about what it is just the encoding in which you want to read this file. And then finally, the third argument you can pass as an anonymous function, which we discussed in the last class. And the two arguments you get here are err and data. Why err first, why data later on? That's just how the person who defined this function sort of wrote it. This is called error first callbacks, in which you first get the error argument and then the data. And then let me just log data. What is the purpose of this specific function, Harkirat? It lets you read from a file. You give it a path of a file. You give it the encoding in which you want to read a file. What is an encoding, Harkirat? It is just, there are various ways you can read a file. You can read them as a bytes. You can read them as bits of data. There are a bunch of encodings you can read it in. The one that we want is if there is hello world written here, or there is hi there from a.txt written here, that is what I want in data. For that, you can use the UTF-8 encoding. And then I say, whenever this is read, console.log data. Let me run this. You see hi there from a.txt, which means our file is being read. This content is being read. This function is sort of running, and eventually this gets logged. Question is, if I put a console.log hi there here, does this run first or does this run first? What do you think the answer is? First hi there ran, then this thing ran. Harkirat, this was above. How did this run first? This ran first because this is also an asynchronous function. Here you delegated the task to someone else, to Kamla bhai, ke bhai read a file. While you are reading the file, because this is an asynchronous call, because this is an expensive call, because it takes time to read a file from the file system, and this is an asynchronous function, you proceed to do your own things. You can do anything here. You can add a for loop, for let I equal to 0, I less than some big number, I plus plus, a plus plus. Let me define an a variable here. You can do whatever you want. As you can see, I'm doing my own mathematical computation. Let me add another log here. Hi there, 2. Now tell me, what will log first? Hi there will log first, but number 2, will this log or will this log? Considering I tell you that this takes very long, longer than the file read. Basically, my question to you is, okay, bhaiya, this takes a really long time. This will resolve before, when the sort of thread is busy here. Will the thread go here while it is busy here, or will it first complete this, and then go to this callback? If you might remember from our Maggie example, I said that the lady came back after 8 minutes, but the guy was still chopping vegetables. The lady waited for 2 minutes. After the guy was done chopping vegetables, did the lady hand over the ketchup to the person? Which means in JavaScript, if your thread is busy somewhere, even if a callback has resolved, even if ideally the control should reach here, your thread will remain busy here until the thread becomes idle. Hakikat, when does the thread become idle? When control reaches here, goes here, here. After this happens, when the thread becomes idle, is when the control will finally reach in the pending callbacks. We will see all of this visually very soon. For now, let me run this so we can just confirm the output and proceed. Hi there to hi there from a.txt. Increase the number of zeros so we can actually see some waiting time here. So hi there gets logged and then it is busy here. By this time, the file has been read. File read takes less than 100 milliseconds. But as you can see, even though the file has been read, control doesn't reach here. The thread is busy here. When the thread reaches here, thread becomes idle, is when it goes to the pending callbacks and actually calls the control actually reaches there. Cool. That's the high level of asynchronous functions. We have discussed two asynchronous functions now. One, set timeout, and two, fs.read file. Cool hai ji. Reading from file system has been delegated to Kamala Didi. Let's look at JavaScript architecture that lets us achieve the asynchronous nature. So now let's get into the second part. Now that we have these asynchronous functions, how is JavaScript actually, keeping track of these callbacks, keeping track of these asynchronous functions, keeping track of what to run next? For this, I would urge you to go to this file called latentflip.com/loop. If you go here, it will actually let you visualize a few asynchronous functions. So let me write some logic here. There might be something already written here. I'm going to delete this. Console.log hi, and then a set timeout that runs after 5 seconds. And then let me add a for loop here. Let I equal to 0, I less than 10, I plus plus. Let a equal to 0, a equal to a plus 1. Console.log a. I have written this code. When I run this code, notice the things on the right. There are 4 things here. Something called the call stack, something called web APIs, something called the callback queue, and this thing that you see here is called the event loop. So there are 4 things at a high level in the JavaScript architecture that make it asynchronous and let it do the things that we've talked about. Let's first ignore everything. Let's just have a simple for loop here and see what all of these get called. Where all does some code reach? Let me click on run, and you will see control is somehow reaching here, and you see some things printed here. Every line of code that is running here is reaching the call stack. What is the call stack? It is what is being called next, what is being put onto the stack to actually run. You can think of it as the line of code that is actually running right now. If I add, a console.log hi there here, then this gets put onto the call stack. And then this gets put on the call stack. Then for loop keeps on happening. Each one of these get put on the call stack, and then finally you log something. Harkirat, why is it called a stack? Seems like only one thing is put here at a time. One small variation. That is true. Only one thing is put here at a time if your code looks something like this. Let me update my code here. Let me say function calculate sum, and the body of calculate sum is what has this. And then let me call calculate sum here. Now if you notice the call stack, it says console.log hi there, it says calculate sum, and this is still in the stack. It means every function that's calling another function is put on the stack. And above it, the current code is running, current code is running, current code is running. When this loop finally exits is when the calculate sum can also be popped off the stack. If there was another function call here, you would see another thing put onto the stack here. So that is at a high level how the call stack works. If you only have synchronous code, this is the only thing you need to worry about. You don't need to worry about web APIs. You don't need to worry about callback queue. You don't need to worry about the event loop. Call stack is where you will see all your functions get placed and all your code get placed if your code is synchronous. Now, let's introduce some asynchronous code here and see what this web API section is, what that callback queue is, what is this event loop. What have I introduced? I said console.log hi there. I said I'm going to make an asynchronous call to set timeout, with this being the callback function, this being the function that needs to be called after 5 seconds. And this is the duration, which is 5 seconds. Then I have a simple let a equal to 0, iterate over a loop 10 times, and then log the final variable. Let me run this and notice the call stack as well as the web APIs section. Save and run. Console.log hi there, set timeout, and then the loop is running. While the loop is running, look, notice this. Oh, happened too quickly. Let's see it one more time. While this is happening here, as soon as set timeout gets called here, something reaches here. A clock starts to run here. What is this? This is Kamala Didi. Kamla Didi is this web API section. It is what you have delegated a task to, specifically the task being wait for 5 seconds, please. Why is it called web API, sir? Because this isn't really part of JavaScript. JavaScript has where, let, const, whatever. It doesn't really had set timeout out of the box, but people realized it is going to be very common, very needed, which is why websites or web sort of introduced it, which is why it's called a web API. This is something that is handled by the browser, not really wasn't part of the original JavaScript spec. That is why it's called a web API. Let's run it again. Let me increase the duration. And let's notice what happens. So maybe 20 seconds. Run. You run hi there. Let's say that's equivalent to you boiling water. You call the set timeout, which is equivalent to you, to delegate task to Kamla Didi. Kamla Didi is doing her shit. And while at the same time, you're doing your own shit, which is you're boiling the water, cutting the vegetables. Two things are happening simultaneously. This is what is the power of asynchronous functions. You can delegate tasks to someone else. Once this guy is done, it waits here in the queue. It comes back to you and says, I'm done. You ignore them. You are busy cutting your vegetables. After your thread becomes idle, which means after this loop will finally break, is when you pull this from the callback queue, put it on the stack, and then that is how things get rendered. This is what I was talking about when I said, okay, while your thread is busy, does not matter what is in the callback queue. You will ignore it. They will keep waiting for you. Kamla Bai will be like, I'm here with the ketchup. You will be like, I don't care. I'm busy cutting my vegetables. When you're done cutting vegetables, when you're done with all your tasks, when you become idle, is when something called the event loop gets finally done. Event loop's job is to check, okay, is there something in the callback queue? If there is, it takes it and puts it on the call stack. And then that function gets called, which in our case is this function right here. So the event loop's job is, okay, after the thread is free, it is idle, it checks the callback queue. Okay, bhai, what is the latest thing I need to put back on the stack? And if there was any asynchronous task that has completed, it can get pulled from here to here. Let's run this one more time and feel free to marinate it. Set timeout gets called, clock starts. Clock is running independent of our code. Code is also proceeding as it is. Clock is running on the side, Kamla Didi going out there and getting some ketchup. Kamla Didi is very slow, taking a lot of time. But once she's done, can she directly go to the call stack? Can she directly be like, Bhaiya, there's the ketchup? No. She will stand in a queue, wait for Bhaiya to finish. Once this guy finishes, once the JavaScript thread becomes free, is when it can pull things from the callback queue, which in this case, it is going to pull this anonymous function, which is this function right here. And that is what will log this. Let's put another set timeout here. This one will be for 10 seconds. Let's run it. You will see 2 clocks running now. Web API is handling 2 clocks. One is running slightly faster, other is running slower. And even though the 10-second clock was put in later, it will go to the callback queue first because it finished first. So even though you asked Kamla Bai 1 to get ketchup from nearby shop later, she comes back fast. So she's first in this queue, which is why she gets pulled first. Even though this code was present later, it will get put here first because it only took 10 seconds. It is in front in the callback queue compared to the second one. Hopefully that's clear. Let's see which one of these two comes first. This guy came first and then this guy came. Cool. Hopefully that is clear. That is a high level JavaScript architecture. At this point, you can say I understand synchronous functions. I understand asynchronous functions. I understand how JavaScript handles them. How is it able to parallelize sort of tasks due to its asynchronous nature? Cool. Let's go back to the slides. Let's see what's next. This is a checkpoint. We understand asynchronous functions versus synchronous functions. Real use of callbacks is something we didn't discuss, but the high level is that bhai, callbacks actually only make sense in asynchronous functions. In a synchronous function, you don't really need a callback. In the last video, I discussed, there is this use case that you can think of, square, return n into n, and cube, which returns n into n into n. And then I said, I'll create another function called sum of something, which takes 2 variables, which are numbers, and a function as an input. And this is a callback function, and it says const val1 equal to fn of a, const val2 equal to fn of b, and returns val1 plus val2. This is what we did in the last section or like last class. And here I said something like this. Okay, bhaiya, I pass in cube as a callback, which is why this is a callback function. That is true. But you can, the only benefit of sending in a callback here was slightly less code repetition. Again, go back to the last video if you don't understand it, to 1.4. But that was the only benefit. You can still suffice without, sending a callback function here. You can simply be like, I'll define 2 functions. One is called sum of cube. One is called sum of square. So you can still suffice without a callback function when you're dealing with synchronous functions. But when you're dealing with asynchronous functions like set timeout, where this guy is like, bro, I need you to give me a callback. Web API is going to handle and put something on the callback queue, right? That something needs to be a function, which is why callbacks as a concept actually makes more sense for asynchronous functions. We used it to explain things in synchronous functions like these, but ideally the real use of callbacks, this thing right here, what I meant here was the real use of callbacks is, bhaiya, they're useful or slash needed. Like you can't really live without them in case of asynchronous functions like this, or even the fs.read file thing that we saw a few slides ago. So this guy also, the third argument here was an anonymous function. This guy also needs to have a function. This guy will be very similar to this web API's thing, control will reach here, it will read the file. After it gets the file, it will put the file content on the callback queue, and then you can pull it to the call stack. And this guy also this is a real use case of a callback function right here. Cool. Alrighty. Good checkpoint here. Take a breather, because after this, two very important and slightly hard to digest concepts are coming: promises and async await. Let's get into it. All right, let's get into promises. As I said, slightly jarring concept, so bear with me through this part. Let's see how these two communicated until now. What was the high level? Timmy would give the task and a callback function. It would tell Simi, okay bro, here is a callback function. When you're done with the task, call my callback function. I will then run the actual logic inside the callback function. Simi does the task, reads the file, waits for 1 second, whatever task has been assigned. And then once she's done with it, she puts her result in the callback queue. This results gets pulled here. If Timmy is free, they will immediately pick it. If not, there will be some time, Timmy will do their thing, and eventually the event loop will pick it up and Timmy will actually execute the callback function. That is a high level of how an asynchronous function call happens in JavaScript. What does the code look like for this? It looks something like this. One function definition, another function definition. What does this function do? It calls find sum with 100. If I call set timeout with this function's name and 1000, this is the asynchronous function. Control will reach here, here, here. This will get allocated to Simi, and then your thing will get logged. After 1 second, Simi will put on the callback queue. You will, from the event loop, pull it and put it back on the stack. That is how this function runs until now. No promises have been introduced yet. This is simple code without any promises anywhere. This code is ugly. Promises are syntactical sugar that makes this code slightly more readable. What does this line mean? This is a very important line. It means it is syntactical sugar. It is just a pretty way to write this. Under the hood, it will still use a callback queue. It will still use the call stack. It will still use the event loop. It is just syntactical sugar, which means it is just a pretty way to write this, a more readable way, a more manageable way, but under the hood still uses callback, still uses all the other things we have discussed until now. Until now, we've only used other people's asynchronous functions like set timeout, fs.read file, things that other people have written. How can we create an asynchronous function of our own? Let's see that. This is the ugly way to create an asynchronous function of our own. I'm going to create a wrapper around the read file function. Basically, I'm defining a function which takes a callback, and I'm saying fs.read file a.txt utf8 function error data callback of data, which means if I ever call Kirath's read function and pass in a callback, whatever the file content that gets read from a.txt gets sent to the callback function, which in this case is onDone, and this data gets logged here. I'm just creating a wrapper on top of fs.read file. You might say, Kirath, that means you haven't created your own asynchronous function. You are just creating a wrapper. Yes, it is just a wrapper on top of the asynchronous function, which is fine. Usually, all asynchronous functions that you will write will be on top of some JavaScript provided asynchronous function like set timeout or fs.read file. Most of the times, any asynchronous function that you define will under the hood use some other asynchronous function that JavaScript provides you out of the box, which is exactly what we are doing here. We defined a function, which is just a wrapper on top of fs.read file. We decrease the number of arguments because we were like, chalo, we know this is going to just read from a.txt. We said we are going to assume UTF-8 is the encoding. We said we are going to ignore the error argument that you get in this callback. We defined a simpler function, which is a wrapper on fs.read file, which does the same thing. And if anyone calls it, they will pass in a callback, and that callback will get called with whatever the contents of this file is. If you want the Timmy Simi analogy here, Timmy's control will reach here, control will reach here, control will reach here. Timmy will be like, hey Simi, can you please read the code base and read the a.txt file, and whenever you're done, please call this onDone callback. And then Timmy goes on to do its own thing. It doesn't have any lines of code here, so it basically sits idle. And then Simi is like, okay, I've been given a callback function that I need to call. Let me go out and read this file. It reads it, Timmy reads it, and then calls the callback function. This is similar to, Simi coming back with a ketchup bottle and telling, ke bhaiya, ketchup bottle has been here, yellow, take it. Similarly, here it reads the file, and once it has read the file, it tells, ke bhaiya, here are the contents of the file, do whatever you want with it, which in our case, we just log it. Cool. One way to create an asynchronous function of your own, but I'm saying again, this is the ugly way. What is the cleaner way? Using promises. How? What is the syntax, Akirat? We will see very soon. Let's move to the next slide. Breathe before you see the next slide. It is supposed to be overwhelming if this is the first time you're seeing promises. You do not need to understand the syntax. You only need to understand the syntax for now. Don't worry about how it actually works under the hood. As I said, promises are syntactical, sugar. So if you want to actually read through what a promise does, you can. We are not focused at that. We are just focused at the usage at the moment. How do you use a promise to create an asynchronous function of your own, very similar to this asynchronous function that we wrote in the last slide. Cool. Let's get into it. Feel free to take a breather at this point. Cleaner way, using promises. Notice the change that I've made on the left. I have defined the function Kirat's read file, and I say this function at the very top. First thing to notice, it does not accept any arguments. It does not have a callback function. Wow, Kirat, if this does not have a callback function, how does Simi know what to call when she's done getting the ketchup or reading the file? We will come to it. But one high thing to keep in mind, if you are using a promise, there are no callbacks. The reason to introduce a promise is to get rid of callbacks, because callbacks are an ugly way to write asynchronous code. Why, Harkirat? Because they do something called, there are a bunch of reasons. Biggest reason is something called callback hell, which we happy to discuss in a later video. But for now, this guy says no arguments, no callback, return new promise. It returns new promise, basically creates an instance of the promise class. This is very similar to new date, the thing we have seen in the past. It is just a object of the promise class. And if you look at it, whenever you're initializing the promise class, you're saying, okay, bhaiya, first argument is going to be a function. The first argument to new promise is going to be a function, which takes resolve as an argument. What is resolve, Kirat? This is where things get a little overwhelming. Haan bhai, so many things. Firstly, you create new promise. New promise has a function. Function has a resolve as the first argument, Kirat. Yes, this is syntax to, slowly take in and breathe. At a high level, it says, okay, bhaiya, ignore this line, ignore this line. It is simply saying, I'm going to read the file, fs.read file, a.txt, utf8, whatever, and I'm going to call resolve on data. And the promise that I'm returning, whoever is getting that, which basically will be this Kirat read file, the person who gets this promise can call dot then on this promise object, and whatever function they're passing here, whenever I call resolve, this data will reach that function. It is sort of a flipped way to send data from Simi back to Timmy. Rather than Timmy giving a callback to Simi, Simi is like, bro, I am going to give you a promise, and when the promise resolves is when you will get the data. That's a high level of how you write the promise syntax. We will slowly debunk this further, but take a pause. Look at the difference between this code, which is same code without promises, and this code, which is same code with promises. Take a pause, maybe run it. There you go. Let's try to run it. Let's copy this gist code. You can do it yourself on your side. Let's paste it and copy this code from here to replicate and run it. What do you see on the right? You see hi there from a.txt. Make sure you have a.txt file here and then try to run it. What will happen? First, let's put a few logs. Console.log inside Kirat's read file. Console.log inside promise. Console.log before resolve. And then finally console.log data. Let's run it again. First thing, inside Kirat read file, which means control reaches here, control reaches here, control reaches here, control reaches here. From here, it goes here and this gets logged. Then return new promise. This guy returns something. Where does this returned value get stored, Kirat? It basically gets stored here. I can actually do something like this, where a equal to this, and then do a dot then on done. Does this sound weird? Abhi tak to we were calling a function and passing in a callback function. Now I'm saying, okay, I'm going to take this, whatever this returns, what does this guy return? It returns a promise. If you look at it, just like I return 0 here, if I want to, or 1 here, or hello world here, I am returning a new promise. If I actually log this and run it, you will see it says promise pending. Whenever this logs, it says promise pending, which means A, the thing that this guy returned, is actually an instance of promise, is actually, which it should be, right? If you look at it, it's basically similar to where P equal to this, and then I'm returning P. I'm returning an instance of a promise. How that does all the asynchronous logic is a different question. But my Kirat's read file returns a promise, which is what I log here. And after I log it, I say a dot then on done, which means, whenever Simi is done getting the ketchup or she's done reading the file, she will call resolve, and this function and this on done, whatever you pass to then, are very closely related. whatever she passes into resolve reaches this onDone function, which is why data gets logged finally here. Let me remove all the logs. Let me also just simply return new promise here. And now if you look at it, you see inside promise, this log right here, you see before resolve, this log right here. After resolve gets called, the JavaScript engine sort of checks, कि भैया, whoever has done this promise dot then, which a dot then we've done here, whoever has done it, I am going to call it, which in this case is onDone. That is how promises ka syntax differs from that of callbacks. Let's see this more visually. Let's see how Timmy and Simi talk now. Timmy says, can you read a file? Promise me please, Simi, or Simarpreet, which is the name I've given to this lady right here. Simi is like, sure, here's a promise. She returns a promise back to our guy here. I may or may not resolve this promise in the future. Returns it immediately. She immediately says, bro, ye lo promise. She sort of synchronously returns the promise. She does not synchronously return this data, but she does synchronously return the promise. That is why I was able to log it right here, because when the JavaScript thread runs, it reaches here, it reaches here, it reaches here, it gets back the promise synchronously. I can then log it right here. But the data of the promise comes asynchronously, comes eventually. And when it comes, it reaches here. So again, Timmy says, can you do this, read this file for me? Promise me please. And then Timmy goes on to do his own things. Simi immediately says, okay, bhaiya, here is a promise. I may or may not resolve it. Please put a dot then on this promise so that I know where to send the data. And Timmy is like, okay, after I read this, I'm going to do a dot then onDone, so that Simi knows ki haan bhaiya, I need to send the data here. Finally, does her thing, reads the file and calls resolve. When resolve gets called with the final data is when whatever was passed to dot then in the promise that was written here, the control reaches there. onDone gets called on Timmy's side, and then Timmy will do his thing and run all the logic here on the main JavaScript thread. Cool. As I said many times, this is just syntactic sugar. This is just to make this look slightly cleaner. You might ask, it does not look cleaner, actually looks very difficult. I say yes. Compare both the code bases. Compare the code on the left uses callbacks. Code on the right uses promises. Ideally, especially if you're seeing this for the first time, looks much easier to understand. Ki haan bhaiya, Kirat read file and pass in the callback, so that Simi knows कि भैया Timmy has given me this callback. I'm going to read and simply call the callback. Control reaches here. Thing on the right, technically pretty code, but I can get why it's jarring the first time you see it. Now the function returns a promise, and whenever Timmy calls it, Timmy says कि bro, please do this thing for me. Simi says, sure, ये लो आपका promise. Here is your promise. Timmy says, okay, promise dot then onDone. And Simi does her own thing on the side, fs.read file. Once she's done reading, she calls resolve, which since dot then was called on this promise with the onDone function, the resolve makes sure that the control reaches here. The JavaScript engine takes care of all of that. Cool. This is a high level of what promises let you do and how they let you theoretically make the code cleaner, even though it might feel like, yeah, this was less lines of code. This is so many lines of code. There are other benefits to this, which we will discuss in Saturday's class, which is like promise chaining and things like these. But high level, this is what promises ka syntax looks like, and this is how it's different from simple callbacks. Cool. Take a breather. Let's understand a little bit more about this promise class. As I said, it is just a class. If you're initializing something with a new, it is just a class similar to the date class we have discussed in the past. What does the date class do? If I do where d equal to new date, it lets me do, d.getTime or d.get date. If I run this, I see 7 here because today is whatever, 7th of December. So d.getDate, this thing is just initializing a object of a class. Similarly, if I do const d equal to or where d equal to new promise, if I run it, it is similar to me initializing a class, but there is one specific thing about promises. Okay, whenever you are initializing it, you have to give it the first argument as a function, and the function also needs to have the first argument, which is resolve. Can I name this something else? Sure, you can name it R, you can name it onDone. But at a high level, this is the only way to sort of initialize a promise. If I run it now, it runs fine. If I do a console.logd, I see the promise. Even outside a function, you don't necessarily have to, define a function and only inside can you return a promise. No, you can define, it's just a class. You can define the object of the class anywhere. What does it say? It says promise pending. What does pending mean, Harkirat? It means that onDone hasn't been called yet. A promise can at a high level have 3 states: pending, resolved, and rejected. Rejected we will discuss on the weekend. pending and resolved, as the name suggests, कि भैया so let d be this and let me do d dot then on callback, and then me define a function callback, and here let me do console.log d. What have I said? I said कि भैया d is this new promise, d dot then callback whenever d resolves, which doesn't matter what the name is. Basically, whenever the control reaches here, the control should reach this line right here. And if I log d here, you will notice that I am offline, which means my internet is down. Or is it? No, replit is down. This is exactly why we are creating a replit comparator. Let's try that one more time. Yep, not working. Have they blocked me? Do they already know I'm creating a comparator? Okay, let's run this as a new one. Seems to work. And what does it say? Promise undefined. What does undefined mean here? Why is it undefined? It is undefined because I didn't send any data back. When you send Simi to get ketchup, she can come back and say like, oh, don't have anything. Or usually, whenever you call any synchronous function, it will return you some data, like the ketchup, for example. So here, if I return this, is when you will, if replit works for once, you will see foo written here, which means you can actually see the data. Like the promise says foo inside. If I log the same thing outside, which means before the promise is resolved, what would you see? Foo only you see, which means since it is immediately resolved, I'm assuming it gets resolved here. Let's see. Let's put a set timeout here. Basically, that should do it. One second. So now, when d gets logged here, resolve for sure hasn't happened. Resolve is happening after 1 second, and so you will first see promise pending, and then see promise foo. Here, promise state is resolved. Here, promise state is pending. So promise is something you can use outside of functions as well. Usually you use them inside a function, but it is just like any other class, just like a date class that lets you sort of, send data from one place to another place. That is a high level. You can use callbacks for that, or you can use promises for that. Feel free to play with the code base that you see over here. All right. What even is a promise? It is just a class that makes callbacks and asynchronous functions slightly more readable. When you create it, you need to pass in a function as the first argument, which has resolve as its first argument. Promise function resolve. I can totally get why it is jarring, supposed to be jarring. Slowly you will get the intuition of it as you write more functions in it. Here's a simple problem that a promise that immediately resolves. Const p equal to new promise, resolve hi there, p dot then function, and I can log p here. If I run this, what gets logged? Promise hi there gets logged because the promise is resolved by the time the control reaches here. Place for the writer of the async function to do their magic, get the ketchup, and call resolve at the end of the data. So whenever you're defining a promise, the goal is at a high level. You do some asynchronous magic here. You make a database call, you read a file, you wait for 1 second, you get some ketchup. That logic is always put here. And once that is done, once you've done some asynchronous logic, is when you call resolve with your final value. And the thing at the bottom is whatever is put inside p dot then, given p is that promise that eventually gets resolved. This control gets called, dot then gets called whenever the async function resolves. Whenever resolve gets called here, dot then gets called. And the argument to this is the same, that thing that you're sending here. So if there was a data variable defined here, and if I log data, I would see hi there written over there. Cool. Feel free to take a pause at this point. All right. What does this say? Dummy async function that almost immediately resolves. This is a dummy simple. So basically this was without a function. Let me just, put this inside a function so you actually see some use case, even though, this is just a dummy resolve. So nothing fancy happening here. Ideally, as I said, there would be some async logic here, like reading from a file or, waiting for a second. Dummy async function that almost immediately resolves. This is how you write the logic for it. This is how you will write asynchronous functions of your own that are using promises and not using callbacks. Actually logging the data with what the function above resolved with. Value dot then function data. You get back some data and you actually log it to the screen. Cool. This is how you log data. This is how you, after you've called the function, this is how Simi returns data to Timmy. This is how Timmy sort of does whatever he needs to do with the data, which in case of our Maggie example is, he'll get the ketchup so he can do whatever he wants with the ketchup here. All right. Promises. Try to marinate both the sides now. What sides? The calling side and the defining side. Thankfully, you just have to worry about the calling side. You will have a bunch of asynchronous functions which will return promises. You don't have to look at their logic. You just, do call them and do a dot then on them. That's what your life will be usually. You don't have to worry too much about, the logic inside here and writing asynchronous functions of your own. Very less you will have to do it. Most of the times you will have to just worry about calling them. But do get comfortable with both the sides. Cool. Question is, Harkirat, why even make an asynchronous why even make it asynchronous, Harkirat? Seems like you're not doing something that cannot be done with a normal function. Because this, I've not written anything special here. There should be some async logic here, in which case it makes sense to create a promise. Right now I just wanted to show, which is why, this seems like a simple function. Rather than doing this whole magic, I could have simply done this. Okay, don't need to do this fancy magic. Just create a function that returns hi there. Na? Why are you creating a promise and then not doing anything asynchronous and then resolving hi there, which you are also then calling a dot then and then logging here? Just create a simple function, return hi there. Just do const data equal to this thing and log data, Harkirat. Why are you confusing everyone and doing promise mathematical magic wizardy stuff here? And the answer is that works. This is a bad example. This is a good example. What if I told you कि you have to create a function that resolves after 5 seconds, or create an asynchronous function whose job is कि भैया wait for 2 seconds and then resolve, or which can be compared to asking Kamta Bai to go and get ketchup after, and she gets it after 2 seconds. So in that case, look at this syntax and look at this syntax. This is a simple function. So this is how you would do this. If you have to wait for 2 seconds and resolve, this is how you would do this with a promise. This is how you would do it without a promise. This one is, as I said, conventionally ugly. कि भैया you call it and give it a argument which is a callback function and that logs, and this guy calls set timeout to call back after 2 seconds. This guy is the promisified version of this asynchronous function. Again, this is just a wrapper on top of set timeout, just how we created a wrapper on top of fs a few slides ago. The Kirat read file, which was just a wrapper on top of the fs.read file. Similarly, I'm creating Kirat async function, which is just a wrapper on top of the set timeout function. In case of promises, it is const p equal to new promise function resolve. Again, syntax you have to get comfortable with. And what does it say? It says call resolve after 2 seconds. And whoever calls this function and does a dot then, basically this will log after 2 seconds. This is the promisified version. This is the conventionally ugly callback version. Both do the same things. This is just syntactic sugar, which means this just sort of, you can think of it like this also converts under the hood into this only. This is just meant to be slightly more readable, because dot then do something is slightly more readable than Kirat async function passed in a function. God knows what does this function mean. What is this callback thingy? If someone does not understand callbacks, this is much more readable. Value or Kirat async function dot then, which means after this is done is when you can call some logic here. Cool. That's a high level of promisifying a async function and non-promisified async function. Now we've discussed 3 things. We've understood asynchronous functions versus synchronous functions. We've understood JavaScript browser architecture, event loop, call stack, things like these. We've hopefully understood promises. We will revise this again in the Saturday live class, but hopefully we at least get a high level understanding of what a promise is. Just a class, and it is used to sort of replace callbacks. It is just a cleaner way to write asynchronous functions on your own. Last thing I have to discuss is the real benefit of promises. Abhi tak to this felt like they're both very similar only. What is the benefit of this over this? This actually looks uglier. But if you are using promises in your code, there is another way to do this thing. Rather than doing value dot then, you can do something else, which is much more cleaner. That is what gives promises the power it does. That is why everyone loves using promises, because of the async await syntax. So let's discuss that next. Async await syntax again is just syntactical sugar. Still uses callbacks and promises under the hood. Just a easy way to write code. Under the hood is still using callbacks. Under the hood, still the event loop is running. Still the callback queue is there. Call stack is there. Everything is there. Cool. Normal syntax, the promisified syntax that we used until now. Define a function, let p equal to some promise, return p, and this guy says call this thing, gets back a promise, dot then log this value. Hopefully this is clear. If not, let me copy this and open it in Replit. If I run it, what do I see? It says hi there. How does the control go? Function is defined, main gets called. Inside main, Kirat async function gets called, and I say, bhai, whatever promise you return, dot then, please call this. I delegate a task to Simi. Simi is like, okay, I'm going to define a promise and return it to you, and this is my body, which immediately is resolving. Again, you should ideally do some async logic here. We are not, but ideally you should, do a function call, a file system read, do a set timeout, do something. Only then it makes sense to promisify the whole thing. If you're immediately resolving, rather make this a synchronous function, similar to what we discussed a few slides ago. Cool. This looks good. This syntax is okay, Harkirat. But let's make it slightly more cleaner. I'm going to add a few things here. First thing I'm going to add is, in front of function, I'm going to write async. Async. What does async say? Async means asynchronous. It means this function bhaiya is now going to be asynchronous. Another thing I'm going to do is remove the dot then. And I'm going to be like, let value equal to this. I'm going to be like, let value equal to Kirat async function. If I log value here, what do you think will get logged? Do you think Haider will get logged, or do you think something else will get logged? Puzzle question for you. It logs promise Haider. It does not log Haider. If I put a set timeout here, that resolves after 1 second. What do you think will get logged here? Promise pending gets logged. I'm not getting the value here. But if I put await in front of it and then run it, you will see it says hi there. Wow, Harkiyat, beautiful. I introduced 2 keywords and that made me get rid of all the dot then syntax that we had to write. This is so difficult to understand so ugly, but doesn't this look very clean? Even though this is an asynchronous function, I don't have to use callbacks. I don't have to use promise ka dot then syntax. No callbacks, no dot then syntax. If a function is returning you a promise, you can put await in front of it and you can be like let value equal to await this, and if you log value, you will get the finally resolved value. Until then, this control will sort of not go beyond it. Kirat, when you say not go beyond it, do you mean if I log whatever console dot log Haider 1 here, when do you think Haider 1 gets logged? Do you think it gets logged after 1 second, or do you think this gets logged immediately? Let's make it 3 seconds actually. Let's run it. 1, 2, 3. After 3 seconds, this got logged, which means it seems like the thread is hung here, Harkiyat. It seems like you've written bad code, as when we had written the dot then syntax. If I wrote something like this, value. If I wrote something like this, Harkirat, in this case, Haider would get resolved immediately. I would see Haider 1 immediately, and Haider will come later on after 3 seconds. But Haider 1 comes immediately, as you can see, comes immediately. And when you converted this into this, let value equal to await this thing, it seems like you stopped the thread here because Haider 1 does not get logged for 3 seconds. Does this mean you are making the thread busy for 1 second or 3 seconds here, and not asynchronous stuff is happening? No, asynchronous stuff is still happening. The thread isn't stuck here. Thread is waiting here. As I said, under the hood, same things are happening. Under the hood, this is promise only and promise is callbacks only. So if I write some random other logic here after main, for example, I don't know, console.log after main. If I write this logic here, main gets called, control reaches here, it will not get stuck here. It will move on to main, it will move on to other things. And whenever this resolves, thread will start from here. Let's run this and see. After main gets called immediately, which means control reached main, reached here, let value equal to await this. It is awaiting here. It is like, it basically is somewhere put on the web API section somewhere. And while it is there, the stack continues. The control reaches here and this gets logged. And eventually this await succeeds and value comes here and you log Haider 1 and you can log the value as well. Sure, all the logic after this is stuck, but that is a conscious decision. When you say await and put some logic after it, it is the same as saying dot then value. It is the same as saying this. In this case also Haider 1 gets stuck, right? It will not immediately get logged. It will take 1 second or 3 seconds for Haider 1 to get logged. So similarly, just how it takes 3 seconds to Haider 1 to get logged here, if I use the await syntax, still it will take 3 seconds for Haider 1 to get logged. It is a conscious decision by the developer. Ki, I want to await. I don't want any logic after this to run because I might need the function of this, the value of this in the logic here. Cool. That's a high level of the async await syntax. Let's look at the code again. Thing on the left, promisified syntax. Thing on the right, async await syntax. What did I add? I added async here. I added await here. That is the only high level difference. No need for dot then. Very simple, clean way to write it. Await is very important. If you don't write it, what you get back is the promise itself. If you write await is when you get back the resolved value. Again, it's just syntactical sugar. Still uses callbacks, promises under the hood. Makes the code much more readable than callbacks and promises. Usually used on the caller side and not on the side where you define the async function. Usually used on the caller side, not on the side where you define the async function. What does that mean? That means whoever is calling it has async await here. The person where you've defined the promise, you don't see any async here await here. You can actually add async here. There are ways, but this doesn't need to have async. The caller, the person that is calling this, needs to be an async function and needs to have an await here. At this point, a good thing to ask my dear, why did you introduce this main thing here? Why not write this here directly? Why did you not write this here? Why did you introduce that main function? The answer is this. Paran this, it says await is only valid in an async function at the top level bodies of modules. Basically, you cannot put await at the very top level. Every await needs to be wrapped inside async, which is why I had to write async function main here and then call main. I did not await main here because I cannot await at the top level. I simply called main, and then main sort of is an async function. I was able to await inside it. I cannot await outside it. Going back to the slides, it says any function that wants to use await needs to have this async keyword in front of it. If I remove this async keyword from here, it will start to complain for me. Await is only valid inside an async function, which means I need to put async here. And secondly, what does it say? Rather than using the dot then syntax, we add await before and get the final value in the variable. That's a high level of the async await syntax. Next slide. Again, both do the same thing. In fact, all three do the same thing, sir. Callback syntax, promise syntax, async await syntax. Depends on you what you want to use. All three do the same thing. This guy also calls this thing, should ideally do some async magic here. Callback, control reaches here. This guy also calls this thing, gets a promise, dot then control reaches here when resolve happens. This guy also says const value could await this thing, control reaches this value when this gets resolved. All do the same thing. This ideally is just the cleanest, easier to look at, pleasing the eyes, because no dot then, no callback, no nesting, everything happening line after line. This is why people love the async await syntax. Still uses promises under the hood, promises still use callbacks under the hood. Cool. That was the last slide. Thank you everyone for joining. Hopefully this makes the upcoming week easier, because this is a very jarring concept. Promises, especially the first time you